Alright, so we're going to discuss Kirchhoff's laws or Kirchhoff's rules for circuits. So be careful if you're Googling any information. Kirchhoff also did 3 laws for spectroscopy, which we will not be learning about in this course. So the first rule is the junction rule, and this says that at a junction the sum of the currents has to equal 0. And a junction is where 3 or more conductors meet. So if we have wire 1, wire 2, wire 3 coming together, there would be a junction point here. And you can sort of think of it like the flow of water. There's one river coming this way, one river coming this way, so the volume of water coming through here has to be the sum of this one plus this one. So I would say I3 equals I2 plus I1. For the loop rule says that the sum of the voltages has to equal to 0. And if we don't use all of our potential by the end of the loop, we end up with a buildup of charge on one end, which creates an electric field in the opposite direction. So this is why you have to have a closed conducting path. So the loop is a closed conducting path. And the sum of the voltages, so as you go across each circuit element, by the time you're done, you have to be out of potential. So the sign rules for when we go across circuit elements that are potential drops, so things like power supplies and resistors, and meters also, they're also wired into the circuit. When we go across a power supply, if you're going from negative to positive, the potential is positive. But if you're going from positive to negative, the potential is going to be negative. And when you go across a circuit element like a resistor, if you're going across the resistor opposite to the current, I times R is going to be positive. And if you're going in the same direction as the current, I times R is going to be negative. So now we're going to next go through a couple of examples on how to apply these rules in order to learn about different portions of the circuit.